So section 1.5 is talking about angle relationships. We're going to go over a couple of terms that we're going to use throughout the year. We're going to go through pretty quickly, and we're going to name a lot of letters of angles. And it's going to sound very similar from example to example. So if you get lost, if you're confused on letters, rewind it, hear it again, watch it again, follow along with the letters. I'll try to move the mouse along with where I'm talking to help you follow along. All right, so we've got our 5 essential angle pairs. We have adjacent angles, complementary angles, supplementary angles, linear pairs, and vertical angles. And I already went ahead and typed in the definitions to help you out. Adjacent angles are next to each other, or you could call it side by side. Okay, so adjacent angles, if I were to draw 2 angles here, angle 1 and angle 2, those are adjacent because they're touching, because they're next to each other. That makes them adjacent. Now, complementary angles, supplementary angles, linear pair can be adjacent angles. Vertical angles cannot. So complementary angles, they add up to 90 degrees. Another name for a 90-degree angle is a right angle. So if it's a right angle, and you have your third line, we have angle 1 and angle 2. Supplementary angles add up to 180 degrees. 180 degrees, remember, a straight angle. So we have a straight line, pretend that's straight. And from there we have any line drawn. Now that could be anywhere in there. Angle 1 and angle 2. Angle 1 and angle 2 form a straight line when you put them together. That means it's 180 degrees. Now when it says see above picture for linear pair, I'm talking about that one. Linear pair are 2 angles that make a straight line. The reason I say there's another example here is supplementary angles. I could draw one angle here, call it 80 degrees, and I could draw another angle, call it 100 degrees. Those are supplementary as well because they add up to 180. This picture you'll see more often because it's supplementary and it's a linear pair. And vertical angles are across from each other. You need 2 lines for vertical angles. Line number 1, line number 2. Vertical angles are across from each other, 1 and 2. Okay, and then later on we're going to talk about some special properties of vertical angles as well. So let's start with adjacent angles. We've got this picture here. An example of adjacent angles are SRT and TRU. The 2 small angles, if you were to cut it in half, those 2 small angles are adjacent angles. A non-example, something that isn't true, is SRT and SRU. SRT and SRU are laying on top of each other, so they can't be adjacent angles. They have to be completely separate angles that happen to share one line in the middle, one common ray. So, vertical angles are non-adjacent angles formed by 2 intersecting lines. Here we have 2 intersecting lines. 2 and 4 are across from each other. 1 and 3 are across from each other. When you look at vertical angles, think of a cross. 2 and 4 are across from each other. Okay? And if two angles are vertical, then they're congruent. That's a theorem we're going to use, or a definition we're going to use throughout. If 2 angles are vertical angles, then they're congruent. And these are not vertical angles. They might be congruent. We don't know, but they're not vertical angles because we need 2 straight lines. These 2 are 2 straight lines that form an X. These are 2 lines that connect to a straight line. So we take a look at the difference between these 2 pictures, why this one on the left makes vertical angles and why this one on the right doesn't. Because it's not 2 straight lines, it's actually 3 lines there. Alright, linear pairs. They're adjacent angles whose non-common side are opposite rays. Essentially meaning makes a straight line. Keyword, 180 degrees. Angles 5 and 6 over here on the left are they're a linear pair because they form this straight line. Over here, this line's not a straight line. Since it's not a straight line, not a linear pair. If you have a linear pair, then the 2 angles are supplementary. And remember, supplementary means 180 degrees. So a linear pair is supplementary. They add up to 180 degrees. Now take a look at this example. Look at the picture. See if you can name a pair of vertical angles, a pair of obtuse vertical angles, a pair that's a linear pair, a pair of complementary angles, and a pair of supplementary angles. All right, take a minute, do that, then we'll check in just a second. So, vertical angles across from each other. I'm talking like 1 and 4. 1 and 4 are made by two straight lines. Okay? Obtuse vertical angles. So obtuse vertical angles are two angles that are bigger than 90 degrees. Angle 5 is bigger than 90 degrees, and the one across from it, we can't use a number to name it. We have to use 3 letters. So I'm going to use angle 5 and angle LDO. A linear pair makes up a straight line. Here's a straight line. Angles 4 and angle 5 make up a straight line. You could have also said angle 1 and angle 5. Complementary angles. They got to add up to 180, or I'm sorry, complementary add up to 90 degrees. 90 degrees, here's a right angle. So angles 1 and 2. And last one, supplementary angles. Remember, linear pairs are supplementary. So you can use your answer from number 3, or from letter C, to answer for letter E. Angle 4 and angle 5 make up a straight line, which means they make up 180 degrees. Alright, we got a definition. Perpendicular. If two lines form a 90-degree angle, then they're perpendicular. We've got this mark in here. Anytime you see that mark, it's talking about perpendicular. Alright, we're going to use this upside down T to represent perpendicular. So when we talk about these two lines, what we're going to say is that line AC, remember it's got the arrows, is perpendicular to line DB. This tells us, this is a statement, a conjecture we make anytime we see that mark in that corner. So let's try an example. Find x so that the two lines are actually perpendicular, the two rays. We want to see, is this actually a right angle? Can we prove that that's a right angle? Well, a right angle is 90 degrees, so my two angles inside have to add up to 90 degrees. If they do actually add up to 90 degrees and we find an x value that works, that means that those two angles are going to be complementary. So we combine like terms. 9x and 3x is going to get us 12x. 5 and 1 add up to 6. So we got 12x. I'm going to subtract 6 from both sides, get 84. Divide by 12, and we get 7. I found an x value that works, which means these two angles are complementary. Now, the question doesn't ask us to do it. Let's go ahead and find the actual angles, though. 9 times 7, plug it in, we get 63, plus 5 gets us 68 degrees. Plug in 7 down here, 3 times 7 is 21, plus 1, 22 degrees. If you double check, we get 90, so it actually does work. Now here's the question that you'll see that it takes a little time to figure out what it's actually asking. If two angles are supplementary, just stop right there for a second. Up to that point, supplementary, so we're talking 180 degrees. So two angles are supplementary, and one angle is 18 less than the other. So let's say angle 1 is x. Angle 2 is 18 less than that other angle. That means x minus 18. Now I have two angles, and I know that they're supplementary. Angle 1 and angle 2 add up to 180 degrees. So x plus x minus 18 has to equal 180. 2x minus 18 equals 180. I'm going to add 18 to both sides, get 2x equals 198. When I go ahead and I divide by 2, I get 99. I get x equals 99. The question is asking for us to not find x, but to find the measure of the angles. Well, this one over here is done. That's 99 degrees. But I want to plug in 99 right here. I want to take 99 and I want to subtract 18. That's going to get me 81 degrees. My two angles, 99 and 81, are 18 apart from each other, and they're supplementary. So remember, when we're going through this, take your time, read the angles, double check that you're looking at the appropriate angle, set up your equations based on the vocab that we talked about: supplementary, complementary, linear pair, adjacent, and vertical angles.